So we've looked at how to measure a rate of reaction, how fast a reaction goes, and now we're just looking at how a reaction actually occurs. So a reaction must do the following three things in order to actually happen. So the first one is that the particles must collide. So here I've just got a picture of the particle missing, and here the two things actually combine, actually get physically close enough to touch each other. The second thing is that they must hit in the correct place. So I've tried to illustrate that by hitting the shield, and this one actually hitting the guy. All right, not hitting his armor. And so we call that the correct 3D alignment or 3D orientation. Now a good one for that is I2 plus H2 reacting, where you've got it makes a lot more sense that they have to hit in that direction in order to get two HIs rather than hit along this axis here. And so the third one is, even if you hit in the right place and you actually hit, you have to have enough energy. If it's too light, it's just going to not affect anything. So it's not going to kill the Spartan, is the analogy that we're using. Okay, so particles must have enough kinetic energy to overcome the electron cloud repulsion to react. This is called activation energy and is directly proportional to the temperature in Kelvin. Okay, so the quick and easy answer is you must have enough activation energy, basically, to break the bonds. So don't forget, when you're explaining the rate of reaction, that you don't stop here, which is what a lot of people do. Don't say that just increases the number of collisions. That's not going to work. All right, it increases the number of collisions. The more collisions increases the probability that it will be in the correct 3D orientation, and more collisions also increases the probability that collision will have enough activation energy. So if you collide in the correct 3D orientation with enough activation energy, you can get a reaction.